Welcome to Pratham Science Academy classes. And in this video, we are going to start with the chapter 7 of class 12, that is the integrals. So, what are integrals and what is integration? Okay, before this, we have done the differentiation, and we know that. Let's consider this. Let's say that we know this the differentiation of sine x is cos x. And by this, we mean that cos x is derived from sin x. Or we can say this in other way that sin x is entire derivative of cos x, or instead of an entire derivative we can say sin x is primitive of cos x. And now instead of this entire derivative and the primitive we can say sin x is integral of cos x. Okay, now instead of the this differentiating a function, we will now given the derivatives of the function, and we will have to find the primitive ones. So this process, the differentiation goes from here to here. So in this integration, it's just the reverse of the differentiation. That is, we will be given the derivative, and we will be asked to find the primitive or the entire derivative, and we call this as the integral of cos x. And how do we denote this? And so integration is the inverse process of differentiation, and instead of differentiating a function, we will be given the derivative of a function, we will be asked to find its primitive, and this process is called integration or entire differentiation. And how do we denote this? To denote this, we are going to use the symbol, and these are the symbols. And as I told you that the differentiation of sine x is cos x, and we call sine x as integral of cos x. So how do we write this in mathematical form? We will use this symbol. This is the symbol, and we will say the integration of cos x. So x is the variable, cos x is the function, and differential element is dx. So integration of cos x is, we will say, sine x. Okay, now, so that's how we denote the integral of a function with respect to x, where this is our function, this is our function f of x, and this function for which we have to find the integral is called the integrand. So cos x is our integrand, and x in this function is called the variable of integral. We have to integrate with respect to x, and we our questions will be the in the form like integrate or find the integral of, let's say, cos x. So questions will be in this form: integrate or find the integral of cos x. And by this time, we all know that the integral of f means a function f such that the differentiation of function is equal to f of x. And when we integrate this, we get f of x. So that is an integral of f. Now, integration is a process of finding the integral. That is just the reverse of the differentiation. Now, coming on to the constant of integration. And before I explain this, let me just write. Let's say we all know that differentiation of sine x is cos x. And what would be the differentiation of sine x plus 2? That would also be cos x. What would be the differentiation of sine x plus 100? That would also be cos x. So we can say in this case, integral of cos x, or the integration of cos x, is sine x. So cos x integration is sine x, and in this case, the integration of cos x into dx was sine x plus 2. In this case, integration of cos x into dx was sine x plus 10. And now this is our constant. So whatever is the constant, if you fix to the same, that is, it's added to the same function, will give you the same differentiation. And opposite of that, if I have to find the integral of this, that can be sine x, that can be sine x plus 2, that can be sine x plus 10, that can be sine x plus any real number. So instead of writing this 1, 2, so whenever we have to find the integral of cos x, it's sin x, we will just add c because it can be the differentiation of any of the real numbers, which gives us the same primitive. So this constant of integration is any real number c that is considered a constant function. And so that is constant of integration. And these are the formulas. And we know that the differentiation of x raised power n is n into x raised power n minus 1. But when we differentiate this x raised power n plus 1 upon n plus 1, we get x raised power n. So this is the the integral of x raised power n. Okay, let me explain this in this way. We know that differentiation of x raised power n is n into x raised power n minus 1. N into x raised power n minus 1. But to get this as the primitive function, we will have to differentiate this, that is x raised power n plus 1 upon n plus 1. And if we use this formula on this, that should give me n plus 1 into x raised power n plus 1 minus 1. And this n plus 1 is constant, this gets cancelled, which gives me x raised power n. So we can say that the x raised power n. This is the derivation of this. So this is the integration of x raised power n. So integration of x raised power is x raised power n plus 1 upon n plus 1. And regarding this formula, we will never use this for integration of x raised power minus 1. Because if we use this, that would be x raised power minus 1 plus 1 upon minus 1 plus 1, which gives us, if we use this formula, this one, for x raised power minus 1, which will give x raised power minus 1 plus 1 upon minus 1 plus 1, that is x raised power 0 upon 0, that should be 1 by 0, which is undefined. So we are never going to use this formula for x raised power minus 1. Instead of using this, we will just write x raised power minus 1 as 1 by x. And we know that the differentiation of log x is 1 by x. So the integration of 1 by x will be log x plus c. So for x raised power minus 1 is 1 by x, which is log x plus c. Similarly, differentiation of x is 1. So integration of 1 will be x plus c. We will just add a constant to every integration that we do, or that we we will do. Just add c to every integration. Differentiation of sin x is cos x, so cos x integration should be sin x plus c. Similarly, okay, in this case, we know that differentiation of cos x is negative sin x. So to get sin x, we will have to make sure that there's already negative sin x. So this is just the, so for the integration of sin x, it's negative cos x now. Similarly, tan x is secant square x, and we have to remember, we will have to learn all these formulas that's given in the NCERT textbook. And let's move on to some of the properties, important properties. Okay, the first one is the basic one. The process of differentiation and integration are the inverse of each other. That is, if differentiation of sine x is cos x, then we will say integration of cos x will be sine x. and we have to add a constant there. So that is the first one. Now two definite integrals with same derivatives will with the two definite integrals with the same derivatives are equivalent. That is x cubes integration. We know that the differentiation of x cube is 3x square. So we can say that integration of 3x square into dx should be equal to x cube plus c. Similarly, if we do the integrate differentiation of x cube plus 9, that's also equal to 3x squared. So differentiation of 3x squared can be written as x cube plus, sorry, it's integration. So integration of 3x squared with differential element dx can be written as x cube plus 9. And okay, let me do. Okay, so in this case, integration of 3x square and 3x square, its integration of 3x square is x cube, and integration of 3x square is x cube plus 9. So this is the same integration which gives us x cube, and same integration which gives us x cube plus 9. So these both are equivalent, and so we will consider them as the equivalent integrals with the same derivatives. So these are the equivalent integrals with the same derivatives, equivalent integrals with the same derivatives. Coming on to the third property, which says that sum of the integration of two functions, that is f of x. So if we have to find the integration of sum of two functions, this can be written as integration of first function plus integration of second function. That is, if we have to find the integration of sine x plus cos x, so this can be written as integration of sine x into dx plus integration of cos x into dx. So that's our third property. Fourth one says that integration of any real number, the product of any real number with the function, let's say 5 into cos x into dx can be written as 5 can be taken, 5 is constant, so that can be taken out, and now it's integration of cos x into dx. That's our fourth property. And fifth property says that there can be n number of functions with their products. The sum of the products of the n number of functions with the real number, that is, let's say it's 5 cos x plus 4 sine x plus 3 sine x, and we have to find the integration of this. So this can be written as 5 cos x, the differential element dx, 4 into the integration of sine x plus 3 into integration of, it's once again, let's say it's tan x, or let's give it as sine x. So this is the fourth property where we can separate the functions from their real numbers, which are given as the sum of the product of the functions with the real numbers. So I think we are done with this, and do like, share, and subscribe if you like this video. We will now move on to exercise 7.1. Thank you for watching.